All right, hey guys, this is Miss Lastly and Miss Markert, and we're here for day 2 of Unit 7, Discrete Mathematics, Arithmetic Sequences. Here we go, get ready.
Cool, so I'm gonna just kind of run through notes like we're in class and just talk through it. And then if you guys have questions, we have the discussion boards posted so that you guys can ask questions there. But for the most part, we're just gonna talk through the notes and then we'll post it so that you guys can have the notes for today and then go and try and do the homework that's posted in Schoology. So today we're doing arithmetic sequences. So your learning target is that you will be able to identify arithmetic sequences, their rules, and different terms in the sequence depending on what the question is asking you to do. So let's just jump right in. So an arithmetic sequence is a sequence where you add the same number repeatedly to get consecutive terms. So here we're just gonna do when, oh, there it goes, you add the same number repeatedly to get consecutive terms. And then the number being added is called the common difference. So okay, so let's look at just a really, oh, I didn't spell that right. Sorry, guys. There we go, that's better. So let's just look at a super simple sequence really quick. Let's look at the even numbers. So if we have 2, 4, 6, and 8, the number being added repeatedly is 2. So 2 plus 2 is 4. So we just add 2 here. We add 2 here. And we add 2 here. And you're just going to add 2 infinitely to get all of the even numbers. So 2 is our common difference, and our common difference is denoted by the letter D. Pretty straightforward. You should have seen these in Algebra 2, right, Miss Lastly?
Definitely. Algebra 1 and Algebra 2 both covered arithmetic sequences.
Yes, and I had a couple of examples on the daily problems last week if you were following along. Had a couple different sequences up there. Okay, so then we have 2 different equations that we use for arithmetic sequences. The first one is the recursive equation, which you guys also saw in Algebra 2, so hopefully this is a little bit of a review for all of you. So the recursive equation uses the previous term to get the next term. Jumped ahead of myself. Uses previous term to get the next term. So your formula for this one is going to be a(n) equals a(n minus 1) plus d. D is your common difference. A(n minus 1) is your previous term. And then A(n) is the term number that you're trying to find. So just as a quick example, let's find A4. Ooh, that looks ugly. And let's do that given the sequence 0, 3, and 6. So 0 is our first term, 3 is our second term, 6 is our third term. And our common difference here is 3, because we added 3 each time to get the next number. So to use the recursive formula, we're going to say that we want A4, and we're going to use A3 plus the common difference, so 3, to find the next term. So to find A4, we would have A4 equals 6 plus 3, so A4 is equal to 9. Oop, drew right through it. Just like that. Except that I can't draw today. That's okay. Cool.
Yeah, now the only other thing, guys, is to remember. So recursive equation is nice if you have the term before it, but it's not always that great. Like say you wanted to find like the 50th term, you would literally need every single term before the 50th term in order to find that term that you're looking for. So it's not very useful, but it does sometimes come in handy. Now, some of you guys had some questions on last night's homework dealing with problems 9 and 10. Both of those questions were in recursive formatting. So if you looked at it, it wasn't this exact formula that we have up here for this problem, the a sub n equals an minus 1 plus d, but it was very similar to this. I think it was like a n plus 1 equals a sub n plus like 3 or something for problem number 9. So just make sure you're looking at the subscript. All right, a sub n is like the term that you're on or the term that you have like previously been given. So just kind of remember to look at the formula. So this one is just like common standard, like if you want to make your own equation, this is what you would use. But sometimes you might be given a recursive equation and then you just have to make sure that you use the information given. It changes a little bit depending on different types of problems. But yeah, so it's nice to have a recursive equation, but you definitely have to know the previous term if you want to find the next term. That's the only downside with recursive equations.
Mm-hmm. Which is why there's 2 equations. So our next one is the explicit one, which
Exactly.
doesn't require you to use the previous term. So let's talk about that for a second. So this one uses the term number to find the equation. And so what we mean by that, so let's just write that down really quick before I jump ahead of myself. The term number to find the value of that term. Okay, so for this one, say we want to find, again, A4. We would use 4 to find it. So in our equation that we're given, so just our general equation, we're using AN equals A1 plus D and then N minus 1. So here, this is your first term. Again, D is the common difference. And then N minus 1 is the previous term. And then for a quick example, we are going to do, what did I have written? So if we want to find, say, the second term, let's just go back to our, I don't know, our evens really quick, since it's a simple one. So if we have 2, 4, 6, 8, and we know that our common difference here is 2, so D equals 2. To find, say, the 10th term, so let's find a 10, we would take the first term, so 2, plus the common difference, so 2 again, and then N minus 1. So we wanted to find the 10th term, so we're going to do 10 minus 1. So we have 2 plus 2 times 9, and this is going to end up being 20. If it updates, there we go. And so this one is really useful because you don't have to find all of the previous terms before it. So it's really handy if you want to find, say, the 120th term of something. This one's really useful to have. I believe on your homework, we don't ask you to find recursive equations. I think it's just the explicit equations. But sometimes the recursive equation is nice if you know the term before it. So, yep. Anything to add to that one, Miss Leslie?
Nope, I think that one's pretty good. You guys should have seen a lot of the explicit equation last year in Algebra 2. We kind of focused on that one the most. So hopefully that one seems pretty familiar to you guys.
Sweet. Okay, so I do have a couple examples, just really quick, so that you guys can see a few of them worked out. So let's talk about that. So for these, we're asked to find the common ratio, not ratio. I don't know why there's an M there. Let's delete that.
It's fine.
It's fine. It's isolation day. I don't know what.
Look, we are just making it through the day right now. Like, can we just be real? Not prepared exactly for this video, guys. So just be grateful that you have a video.
We're trying our best to get things together for you. We're kind of winging it. All right, so we're gonna find the common ratio, a recursive equation, just so you guys can see what it looks like, the explicit equation, and then we're gonna find the fifth term in the sequence because that's the number we picked. So our common ratio for that first one is gonna be 1/3. So every time that we go one sequence, it's gonna be 1/3. It's gonna be negative 1/3 actually. Yep. So you're subtracting 1/3 every time or adding negative 1/3, whatever way you want to look at it. That should be a D. I don't know why that's an A. So your common difference there is negative 1/3. Ooh, I might have, let's see. No, I think we're fine. Oh, I did. I think I looked at the wrong. This might be a geometric sequence, isn't it? Yep. Yeah. I was looking at the wrong thing today. Okay.
I was like, I think this is multiplying.
Yep. Okay. Let's come up with an equation.
Adjusting, okay. Guys. No big deal.
Do you have a arithmetic sequence off the top of your head, Miss Lawson?
Sure. 1, 5, 9, 13.
Cool. There we go. That looks better. Which means that that other one is also the wrong thing. Sorry, guys. Well, we'll fix it in a second. Okay, so for this one, we are adding 4. So D is 4. So then our recursive equation, if we look back at this, if we have AN, then we do the previous term. So we have AN minus 1. And then plus the common difference, so plus 4. So to find the fifth term, we're going to do A5. And then, so this would be the first term, the second term, running out of room, the third term, and the fourth term. So then we would take 13 plus 4, and we would get, math skills are escaping. 17. Yep. Yep, cool. Okay, so there's our recursive equation. So this is the recursive equation for this one. And then our explicit equation for this one would be AN, and then our first term, which is 1. So we're going to do 1 plus 4 and minus 1. So again, to find, let's find the, I don't know, the 10th term here. So let's do A10, and then we're going to do 1 plus 4, and you're going to plug 10 in for N. So then A10 is equal to 1 plus 4 times 9, which is equal to 37. Cool. And then fix that one. We'll go over those sequences tomorrow for geometric sequences, but I jumped ahead. Let's do.
I got it. If you want to
Cool.
do, ready?
Yeah.
It's natural log of 3.
Okay.
Natural log 6. Natural log 12.
Oh, we get fancy. Okay, so let's move this down here so that we have room to write. And I'll make that look better in actual math notation later. But for now, we're just going to deal with the capital L right there. Okay, so then for this one, our common difference would be ln of 3, right? You just add ln of 3 each time? No.
Nope. So guys, think about logs, right? When you're doing logs, it looks like we added 3 to go from 3 to 6. But what did we do to go from 6 to 12? So technically it looks like we're multiplying by 2. But remember, when you're multiplying logs, it's really addition of logs. So to go from ln of 3 to ln 6, you add ln 2. Right? To go to from ln 6 to ln 12, you add ln 2. Because when you add logs, you end up multiplying the number inside of the logs. Right? And if you're ever curious, like if you ever get something like this and you don't know, if it's an arithmetic sequence, if you do ln 6 minus ln 3, so you just subtract the two terms, well, ln 6 minus ln 3 equals natural log of 6 divided by 3, because remember, subtraction with logs is actually division. So if you do ln 6 minus ln 3, you get ln of 6 over 3.
And that's equal to
ln and then 6 over 3.
Oh, yep. Sorry, guys.
There we go.
Really not. I haven't had any coffee today, guys. Sorry.
No, I feel that.
ln.
Which simplifies to ln of 2.
Yep.
So there's our common difference.
Cool. Okay, so then again, let's find the recursive equation. So this one would be an equals an minus 1 plus ln of 2. Yep. And then our explicit equation would be an equals the first term, which is ln of 3 plus the common difference, so ln of 2 times n minus 1. And then we're going to find the fifth term of the sequence. So A5 is equal to, and I'm going to use the explicit equation because I feel like it's easier. And we don't know the term before ln, or we don't know A4. So I'm just going to use the explicit equation. So we have ln of 3 plus ln of 2, and then 5 minus 1. So we're going to say that this is ln of 3 plus ln of 2 times 4. So we get 4 ln 6, right? Or what it, I made a mistake.
So the 4 would go in front of the ln 2.
Yep.
And then it would become an exponent.
Oh, that's right.
Exponent rules of logs.
Ooh, so then we get ln of 8
Mm-hmm.
times 3. So then we
Yep.
would have, so here we'd have ln of 3 plus ln of 8, and then ln of 3 times 8. Wow, having them here not to answer my math. 3 times 8 is 24. What?
24. 24.
Oh, and I went off the page. There we go. Wow, I miss having you guys in class to answer my dumb math questions.
And if you look at the equation, guys, remember that makes sense, right? Because basically what we're doing is we're just multiplying by 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 would be 24. How did we end up with 1 too many? 3 plus ln 2, 4. 2 to the 4th, is that 8? Are we sure?
No, 2 to the 3rd is 8. What's 2 to the 4th?
We got there eventually.
What? 16.
So
16. And then 3 times 16 is 30, 48. 48.
Gotta be, because I just did multiplication, right? 3 times 6 is 12. 12 times 2 is 24. 24 times 2 is 48.
There we go.
And it's 48.
Cool.
Cool.
There we go.
There we go. All right, guys. So that is day 2 of Unit 7, Discrete Mathematics. I hope it was entertaining for you guys. We've missed you. I'm sure you've missed us.
Hopefully tomorrow we'll be better prepared and not have weird sequences, but it's fine.
It's fine. It's totally fine. But yeah, so stay tuned for our video. I think we're planning on doing this every day, right?
Yes.
Yeah.
Although Friday's the checkpoint, right? So we would have videos up Monday through Thursday.
Monday through Thursday. All right. So be ready for these Monday through Thursday. I hope it was fun.
Are we still doing the live stream for them on Thursday?
Yes.
Okay, cool.
Yep. I posted that on Schoology for them.
We will be there.
On for a meeting. I promise I might brush my hair on Thursday, guys. I might brush my hair. I'm not guaranteeing.
We'll see.
We'll see.
I might too. We'll see. It's fine.
We'll see. Who knows? It's been a whole thing, yeah? It's been a lot. All right. Well, until tomorrow.
Yes.
Bye, guys.